Hi, my name is Joshua Mendoza. I'm here to do the molecular orbital theory for O2 2- and O2+. So let's get started. First, let's start off with describing our atomic orbital and our molecular orbital. So our atomic orbital right here, right here, right here, and right here is just going to be describing our orbitals, so like 1s, 2s, 2p. Our molecular orbital, which is here and here, you're going to be seeing down in the middle. It's going to be describing our orbitals as our sigma bonds and pi bonds up here for our p orbitals and our s orbitals. So let's get started. So we know that oxygen has a total of, it fills its s orbital completely. Okay. Same for its 2s. And it has 1, 2, 3, 4 electrons for both. But since these are both minus, we're going to add one more electron to each of its p orbitals, okay? So let's look down here first at the 1s orbital. So the way this works is each of the 1s's from here and here are going to donate electrons down here and then up here. So we're going to donate 1 electron, 2 electrons, 3 electrons, and then 4 electrons, all right? Let's go up to 2s. Same thing. We're going to have 2 electrons down in its sigma and its sigma star. And then let's go up to its p orbital. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons we can work with. Now, the way this works is we want to fill the lowest energy right here, and we go up. Okay? So let's, with our 10 electrons, let's start distributing it out. So we're going to have 1, 2, 3, 4, 5, 6. Alright, we're done with our pi and our sigma bonds. Let's go to our sigma star bonds and our sigma pi bonds. So let's look. We have 1, 2, 3, 4, 5, 6. We have 4 more electrons to work with. So we have 1, 2, 3, 4. Alright. So that finishes off for our O2. Now let's go over to our O2+. So let's get started. We're going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So let me erase that. 8 electrons for just O. Alright, now let's look over at O+. We're going to have 1, 2, 3, 4, 5, 6, 7. Since it's O+, we're going to lose an electron in its p orbital. Alright, now let's go through the same molecular orbital process. The s's right here are going to donate. So we have 1, 2, 3, 4. Same with the s's. Now to the p's. We have to work with 1, 2, 3, 4, 5, 6, 7 electrons. So we're going to have 1, 2, 3, 4, 5, 6, 7. Alright? Also, just to remember, this right here, your sigma, your 1s is going to be your bonding right here, and your sigma star is going to be your anti-bonding. It's going to follow the same format up here, here, and here. So anything with the star is anti-bonding. Alright, let's get into this. So it's going to be 1/2 the 10 bonding electrons minus the 8 bonding electrons to give you 1 bond. Like that. This is over here for the O2+, is going to be 1/2 the 10 bonding electrons minus the 5 bonding electrons to give you 2.5. So it's going to look like this. Alright, does the species exist? Yes, and yes. This one is going to be much more stable, where O2+ is going to be not too stable. The bond length, or how far apart the bonds are to each other, this is going to be longer. This is going to be shorter. The bond strength, this is going to be weaker, and this is going to be stronger. And all that means is that how much force or energy it takes to break apart the bonds. The magnetic property, this is going to be paramagnetic, meaning that all electrons are paired, and this is going to be diamagnetic, meaning that some electrons aren't paired. Thank you for watching, and hopefully I get 30 points.